Hey everybody, how's it going? This is Pat Nappy here from PNLearning.net, and I've got another video here for you in the series that I'm doing on the SAT practice test number 2. We've got a part 3 question today. That is the no calculator section, so just put that away if you've got one. We're not going to need it for this one. This is question 19, and there's going to be no multiple choices here, right? This is the student response part of the section, and let's see if we can figure it out. So they're giving us here a circle centered at the origin of an XY plane. And it says, in the XY plane above, O is the center of the circle, and the measure of angle AOB is pi over A radians. What is the value of A? Okay, so if we want to find the value of A, then we're going to clearly need to know the value of this entire angle, right? A is unknown, so we don't really know how big that angle is. So that's the task of the problem, right? Figuring out angle AOB. So trigonometry and sine and cosine, these are all basically things that come from the circle. They're not things that come from the triangle, but we do apply them to triangles. And the reason that we can do that is because if you take a setup like this with a radius OA and a unit circle, we can kind of drop where the radius hits the point A, we can drop that straight down and form a right triangle. Now, let's try to make that triangle a little bit bigger. And let's see what we know about it. Well, if we know the x and y coordinates of point A, which is essentially here, we kind of know the base and the height of this triangle, right? The x coordinate, radical 3, this is going to be your base of the triangle. And the y coordinate 1, this is going to be the height of your triangle. And so at this point, we have to sort of figure out what is this angle right here. This angle we know is pi over A, but I'm just going to let it be something else until we find it. So let's just call this angle X. How can we quickly find angle X? So one of the ways we can do this is to just use SOHCAHTOA trig and to try to set up an equation to solve for that angle. For example, we're dealing with the opposite over the adjacent side, so we might say tan x equals 1 over radical 3. But we don't have a calculator, right? We're not going to be able to actually solve by using an inverse tangent. What you're going to have to do for a question like this is go to your reference table. There's some really good stuff in the SAT reference table. Let's just take a quick look at it. Okay, so here's the SAT reference table, and what we'll notice here up in the upper right-hand corner is that we have two types of what we call special right triangles. We've got, and let me see if I can zoom in on this a little bit more. We've got two triangles here that are special. And why are they special? Well, they're special because they have particular types of angles, right? We have a 30, 60, 90 special right triangle, and we have a 45, 45, 90 special right triangle. On the SAT, these two particular right triangles come up a lot. So anytime you see a right triangle in any question on the SAT, you should instantly think to yourself, is it one of the special right triangles? In this case, we're going to notice some things about the sides of both special right triangles. They're trying to tell us that there is a ratio between the sides. For example, if this shortest side in a 30, 60, 90, if this shortest side is 1x, then this side, the hypotenuse, is going to be twice as big. That's going to be 2x. And this side right here is going to be radical 3 times bigger, radical 3x. And so if we look at the coefficient of the short side, it's 1. And if we look at the coefficient of the base here, we've got radical 3. That is exactly the same situation that we have here in our problem. We have a 1 and we have a radical 3. This should be enough to convince us that this is a 30, 60, 90 triangle. The smallest angle is going to be across from the smallest side, which would be 1. And that means that this angle right here, this is 30 degrees. Okay, so we've found the angle. Now we've got to figure out what A is. So in order to do that, we just take a degree measure like 30 and we multiply it times pi over 180. And if we can simplify, like for example 30 over 1, 30 and 180 have a common factor of 30. We could just kind of divide those out and get 6. But when we convert this, we should get 1 over 6 pi, or maybe it's even better to just write this as pi over 6. That is the number of radians for 30 degrees. And now we just have to kind of take this radian and set it equal to the radians they gave us, right? They're saying that pi over a radians is their angle, and that's equal to what we just got, which is pi over 6 radians. And it then becomes pretty clear that a has to be equal to 6. And then we get our answer. A is equal to 6. So that's it for this question. You actually don't have to do trig. Even though we're seeing something that looks like a unit circle and we're seeing triangle inside of that circle, you don't need any trig to solve it. All you have to do is go back to your reference table and take a look at the special right triangles. Like I said earlier, anytime you have a right triangle in any sort of geometry question on the SAT math section, look at the reference table. Remember to check these special right triangles. You're going to see that 9 times out of 10 on the SAT, when you have a question that deals with right triangles, the quickest way to do it will be using these special right triangles. So they're really actually a very valuable thing to start getting a handle on. That's pretty much it for number 19. If you can think of a better or quicker way to do this question, definitely leave me a comment. If you found this video helpful, give it a like, subscribe to my channel, or maybe share this video with someone else that you know who is going through SAT math prep. I do offer one-on-one and group SAT prep at my website, PNLearning.net, so definitely check the link in the description and find your way over there if you think that's something that might be helpful. That's all I can say about number 19. Thank you for watching, and I will see you guys in the next video.